So discrete data is data where it's a definite number. So for example, if you survey people and the number of pets they have in their house, it would be 2, 3, 4. You can't get 2.3. You can't get 4.7. But the opposite, continuous data, is where you could, it could be 2.5, 7.2. So let's say you survey your class, how many miles it takes from their home to school. You can get numbers like 12.7 miles, 13.2 miles. So another example is mass, so 24.16. Does anyone have any questions?
No, that was pretty good.
Okay, cool. I don't think we went into depth over this, but if anyone has any questions, I don't remember this one either.
Darby, do you remember going over this? No.
I don't think it would be on this
Do you think it'll be on the text?
If anyone has any questions, I could try and answer them by looking at this.
This is more about like statistics. To me, it just seems like more about statistics and like
covering your bases, honestly.
Yeah. So population, this is just from a statistics standpoint, just it's good to know in general. Population is everyone that you're trying to find data about, and then sample is a portion of the population. And usually we use samples because they're easier to measure than, reaching out to every member of the population. Yeah.
Yeah, okay, wait. Okay. Hi, Nandini. I'm sorry, I didn't see you in the waiting room. Okay.
No, it's cool.
Okay, great. So we went over this example in class. If anyone has any questions about it, I could explain it more in depth if needed.
No. This one was pretty straightforward.
Okay. Then sampling techniques. Okay, so I'll go through this. I'll go through the different types of techniques. Okay, so convenience sampling is when it's basically in the name when it's most convenient for you. So let's say you're trying to take a survey for a science fair project and you're in your classroom, basically surveying everyone in your class. That's an example of convenience sampling. Any questions over that?
No.
Okay. So simple random sampling. I remember in psychology, in her PowerPoint, it said that this is the most accurate way to get more representativeness, but it's the most hardest way. So that's just another thing that was in the back of my head. Basically, this is completely randomized, so there's no chance of bias. So it's, let's say you're trying to take a survey of everyone in your grade. You would take everyone's names, put them in a random name generator. You would press generate, and any names that you got, that would be simple random sampling. If anyone has questions, just stop me. Systematic sampling. So basically it's in the name, systematic sampling. So let's say you wanted to do the same thing and you wanted to survey everyone in your grade. So let's say you did it by last name. So every 10th person in the roll, that would be chose for sampling. So systematic sampling. It's almost like simple random sampling, but there's more of a system towards it, and there's more of a structure towards the sampling.
So systematic is more organized then?
Yeah, it's more organized, but it's still random.
Okay.
Stratified sampling is when you divide the bigger population into smaller groups, and groups are known as strata. So basically an example of this would be if you're trying to, I think I said this example in class, but I don't think everyone here is in my class. So if you're trying to find how well people in sports can balance schoolwork, you would separate the grade into these groups. You could say people who play basketball, volleyball, cross country, and then a group where they don't take any sports or any extracurriculars. So based on that, you would choose a number from each of those groups. So let's say you had 100 kids in your grade. You could choose four people from each of those different groups. So so each of those 4 people would be representative of their strata, their groups. And then quota sampling is basically really similar to stratified sampling, but it's in proportion size. So let's say okay, this one I have a bit of trouble explaining. MG, do you think you could help with an example?
Yeah, so it's like if you have, so it's kind of like, yeah, strata sampling, but what's happening here is now the people that your sample size, like the people you're measuring, the data points are proportional to the size of the entire strata. So if I have 100 students, right, and my stratifications are there's 60 female students and 40 male students. Oh. Sorry about that. If there's 100 students, 60 female, 40 male, and I want to do quota sampling, then my sample that I take should also be 60% female and 40% male. So I'm putting a quota on the females and I'm putting a quota on the males. So if out of 100 people, if I only choose 10 people to sample, which isn't the best number, but if I say I choose 10 people to sample, then I'm going to have 6 females and 4 males. Does that make sense?
That's a good way of putting it, yeah.
Well, yeah. Now that makes sense.
It makes sense.
So wait, for quota sampling, could you say like it's more like more numbers are being taken into account?
Yes,
it's along those lines?
proportional.
It's more statistical, proportional, yeah.
So like more like percentages and more like they're just like not necessarily adding more numbers, but like the use of saying more numbers to make it sound like there's more like quota. Is that like kind of quota sampling?
It's more representative. I like to think of it as like very representative in terms of numbers. Like the fraction is very representative. Fraction.
Okay.
I think parts of a whole.
All right, I got you. Yeah, that makes sense.
Proportionate as in like. Got it. Okay.
So should we move on, or does anyone have any other questions?
Move on.
Okay. So we went over this in class, but we could do it again. So 1A, the number of computers you own, that would be discrete because that's a fixed number. The length of a computer monitor, that would be continuous because you could have 12.2 inches, you could have 13.1 inches. And then the weight of your computer, same thing. It could be, this is inaccurate, but it could be 13.2 pounds or it could be 2.3 pounds. And then the number of laptop bags that you have, that is discrete because you can't have 2.5 laptop bags.
Yeah.
Okay, so for number 2. A sample of 100 students is taken by organizing the student's name by classification and then selecting 25 students from each classification. Does anyone have an idea of what that would be?
Isn't that
Sorry, y'all, that was an accident.
that stratified?
Stratified, yeah. That would be stratified because they separated it into different stratas. So it's taking sampling from each of the groups.
Nice.
Anyone have an idea what 2B would be? A random name is chosen, starting with that student. Every 50th student is chosen until 80 students are included in the sample.
Systematic.
That's systematic.
Because it's like random, but also like
Because
like this is every 50th. That's like that thing. Like it's systematic.
Yeah.
Yeah.
And then 2C, a completely random method is used to select 100 students. Each student has the same probability of being chosen at any stage of the sampling process.
Simple random.
Yeah. Simple random because it's completely random, no chance of bias. And then 2D, the population of school consists of 70% mathematicians and 30% non-mathematicians. 7 mathematicians and 3 non-mathematicians are chosen from each grade.
Quota.
Yeah. So basically, a really like giveaway to like find each of these different types of sampling. For stratified, as soon as you see that they're like separating the population into groups, that's a clear giveaway that it would be stratified. For systematic sampling,
it is every.
It would be like a certain way of, it's random, it has random in it, but there's more of a structure to how they choose the names from the random or whatever they're sampling. And then C, that a clear giveaway is when it says completely random and there's no other catch to it. So that would be simple random.
Yeah.
And then for quota, this is also really a clear giveaway when they start using percentages. So like 70%, 30%. So that's a really easy way. Okay,
that's
so yeah. So if you want, I feel like you should write this down. So like just in case like you like blank out on a test, you have these like 4 like ways of like knowing what sampling method it is. And then for number 3, a fishmonger selects 6 fish whose lengths are between 11 cm and 15 cm, 7 fish whose lengths are between 11 cm and 15 cm, and 3 fish whose lengths are between 21 cm and 25 cm to test for taste. Does anyone have an idea what this is?
Stratified.
Yeah, stratified. This was really confusing for me during class because I thought it would be simple random, but Ms. Sinha said they're separating into different groups, so that would be a clear giveaway for it to be stratified sampling. So like if I were to blank out on this, I would just remember what is stratified sampling group. So that would have helped me answer this question.
Right.
So for B, the school newspaper interviews 50 students, 50 high school female teachers and 50 high school male teachers. What would this one be?
Pretty sure.
Is it
Wait.
random?
It's stratified.
Stratified. No,
was-
actually, I don't know.
I was-
confused.
I was also confused on this one, but Ms. Sinha said that it would be stratified because they're separating into 2 groups, 50 high school female teachers and 50 high school male teachers.
Usually, if you see any sort of like group distinction, that would be, yeah, like Mira was saying. Like stratified, I think of like strata. When I think of strata, I think of like the layers of rocks. So that's kind of how I think about it. Is just like there's different groups, and the different groups have like different numbers, and then if you take a certain percentage of that, like Mira was saying, then that becomes the quota.
Yeah, that's the same thing you could do with simple random, and you could do with systematic. So simple random, you start with randomized, but then when you give it a structure, it becomes systematic sampling. Okay, number 3C. Yes.
Can you go back? Okay, so like there's not exactly a system to it though, because it kind of just says 50 female, 50 male. So like, how do you know it's like clearly stratified? Because I thought it was random at first.
Yeah, so it would be stratified because it would be 50 high school female and 50 high school male. It would be random sampling, correct me MG if I'm wrong, if they just said they randomized all the high school teachers and they chose based on a random generator. So I think it becomes stratified when they separate it into gender groups. That's how I think it's stratified.
Yeah, as soon as you see any sort of group, like what's important here is that it's female and male rather than anything else. The biggest, the indicator that this is stratified is the word female and male.
Okay, that makes sense. Thanks.
Okay, 3C. Does anyone want to answer that?
Every
Systematic.
Systematic.
Systematic, because it's every 4th song from a randomized playlist. Okay, 3D. The mathematics club uses a computer to generate 50 random names and then pick students whose names correspond to the numbers.
Simple random.
Simple random.
Yeah, because it's completely random. There's no structure to it. And then 3F. A local newspaper selects to interview people at the seaside. It specifies that 90% of those interviewed must be local residents and 10% must be tourists.
Quota.
Yep, quota, because you're trying to find the proportionate from the population and apply that to the sample. Oh, that's it for this PowerPoint. Okay.
On to the next.
Here, let me.
Does anyone have any more questions on this PowerPoint?
No, I think like the biggest part about this like section is just like memorizing like what the sample really means, and as long as you like memorize a good example of each sample, I think you'll be fine during the test.
Yeah,
that's what I think.
Darby, I know you had some questions about quota. Did you get does this clear it up now?
Yeah, I just had that last example. It kind of, I mean, I knew it was quota, but then it's also like you don't know the actual size of the population, so how is it proportional? But then
a general rule of thumb, I'd say, is if you see percentages in the question, it's quota. Generally, you always read the whole thing, but generally, if you see percentages, it's quota.
All right.
Okay, so moving on to this next PowerPoint. Here's PowerPoint. Okay, so I think this is just the introduction. I was really distracted when she was going through this in class because I was trying to fix my attendance. But if anyone has anything to say, go ahead and say it if you have any questions or anything.
For me, I guess like the biggest part about the whole frequency, like when she was doing this, when she was doing this PowerPoint, or maybe the one after that, that's when she would explain how to use the calculator. So I guess like the bigger part for this, as long as you put in the numbers right into the calculator, then like it should be fine. Because right after when you calculate it, it'll give you like the mean, the median,
Yeah.
and all that.
So like, yeah, what Charlie was saying is the most important part of putting in the numbers in the calculator is make sure they're all the same numbers from your data. Because like if you mess up one number, you get the wrong answers for every single part.
You have to make sure like right after when you put when you're about to calculate it, make sure it's like L1 and L2 or like for my calculator, at least it's L4 and L5. So like let's say if you put like L1 and L5, then like it might put something completely different.
Yeah,
like
exactly.
you should probably like set up your calculator the day of the test.
Yeah.
Or like a couple months before. But yeah, that was pretty straightforward.
You can do that on Desmos for frequency.
I don't know actually.
There's
know
ways
about
to do, like you can do a lot on Desmos, but let me get back to you on that. I'll search it up, and because there's a lot you can do. Like you can even enter tables into Desmos. I didn't know that until last year. I just found out, and it was the coolest thing ever. But we'll see.
Yeah, because like the TI-84, that's like the main calculator our school uses, right?
Yeah.
Yeah, we can go to the next slide.
Okay. So this is just frequency, putting how much of each next to the number. That's pretty basic standard. And these are all discrete because they're set numbers. That's also standard.
Right.
Okay, so basically histograms and bar graphs. The basic giveaway to identifying a histogram is that the bars, they don't have gaps in between them. And then bar graphs, they do.
Okay,
Yeah.
But like but they still both have the same meaning, right?
Yeah. Wait, actually, MG, I'm kind of confused on what's the actual like conceptual difference between both.
Oh, between bar graphs and histograms?
Yeah.
Oh yeah, sure. So bar graphs is you're looking at each value, right? So if I have at x equals 2, how many do I have? I have 8. So I'm at 2, I'm going to label 8. Whereas histograms are all about intervals. Histograms are all about, okay, between 1 and 2, how many values do I have? So here's a good example. So for bar chart, I might think, okay, let's say students have numbers in a class, right? There's student 1, 2, 3, 4, 5, and 6, and then we want to measure the number of cans a student brought in for a food drive. So student 3, I would label at 3, I would label 5, at 6, I would label 10, at 2, I would label 4, however many they brought in. However, histograms work well with something like, okay, between 1 p.m. and 2 p.m., how many people visited the store? Between 2 and 3, between 3 and 4. That's why do you see the lines, the bars are between the lines, whereas with bar charts, the bars are on the lines.
Okay, that actually makes a lot more sense.
Okay, yeah, that does make more sense.
Okay. So like you can see like bar chart is more like individual rather than grouping, right?
Yeah.
Something along those lines.
Yeah.
Okay, that makes more sense.
Also, MG, could you explain this section, like the skew part?
Yes. So skew is all about how it's kind of like, think of it more as the shape of, like, if you were to take the tops of the bars and draw a line over it, think of it in terms of the shape rather than the bars themselves. So as you can see, the middle one is what we call a normal distribution, meaning everything is, the data is equally spread apart. So we have the mean, which is the highest because it's the most frequent, and then we every standard deviation. I don't know if you guys have learned about that yet, but it's all about equally distribute. It's equally spread out on both the left and the right. If it's skewed to the right, that means if my mean is here, the tail is longer on the left side. So your mean is further towards the right than towards the left, right? So if I have, let me see if I can annotate. Yes. So if this is my shape, right? It's clear that that there's more on the right side than there is on the left side. And what we call this is a tail right here. So because it has the tail, we know that more of the data is clustered toward the maximum than the minimum. Whereas if I had a right or positively skewed data, that means we have a tail on the right side, and we have a skew over here, meaning that that mean is shifted over and that more of the data points are clustered around there. I know the names seem a little unintuitive, like left. When we say left or negatively skewed, that means that there's more on the right, and then so instead of thinking about it in where more the data is, think about it more in terms of which side the tail is on. So if it's left skewed, then the tail is on the left, and if it's right skewed, the tail is on the right.
Okay, that makes sense.
Yeah, so if I were to take down anything from a slide, I would say if the tail's on the left side of the graph, it would be negatively and left skewed. If it's on the right side of the graph, it's right/positively skewed. So I would make those notes.
I'm right.
And then also, like, if a test asks you to like differentiate what's a bar chart and what's a histogram, histogram has no gaps in between, and bar chart stands by itself.
Yeah.
Okay, I'm gonna move on. Okay.
How much in minutes is 15?
Okay, so basically they took the data from here and put them into these frequencies. So these are the frequencies in between 0 to 4. So based on the data in the chart, they put that onto the graph. So as MJ was saying, there are 8. How much time? Okay. There are 8 teachers who took in between 1 to 4 minutes, hours. Wait, why does it say T hours when it's minutes? Am I missing something?
Group of 37 teachers rest how much time?
T represents time.
You might have put a typo.
No.
No, I think.
So,
oh.
Go ahead.
No, actually, I have no idea.
So I think what's going on is from hours 0 to 4, 8. There's. Oh wait, no. You're right. It should. I think.
Honestly, yeah, that's just a typo. Don't mind that. Just look at the time.
Yeah.
So from 0 to 4 minutes, there are 8 teachers who take that much time to eat lunch. So between 0 and 4, you could clearly see there's 8. And then for the next one, between 4 and 8, there are 12 teachers. And then basically the same thing repeats.
All right.
Yeah. Anyone have any questions?
So probably on the test, should probably ask us just to draw the chart, I'm assuming. Mm-hmm. Or maybe she'll show us a histogram and she'll make us make a chart. So either way, it's just.
Yeah, I feel like histograms, you'll always have this frequency thing. And then for bar charts, you will always have a chart like this. So I think that's also another main difference. Okay, so mode. A mode is a value that occurs the most in a set of data. So for example, in these set of numbers, it would be 7 because it recurs the most. Also, there could be more than one mode. So let's say
like 3.
Let's say 3 repeated 3 times. The modes would be 7 and 3. So don't always think there's only one mode. There can be more than one mode. Okay, so this kind of did trip me up when I was looking at the bar graph, but right here, when asked for the mode, it would be, so when you draw the data, you would draw 0 3 times, 0 0 0. And then when you're asked like the raw data, hats, you would say 1 1 1 1 1 1 1. So based on that, if you're ever confused and you're given a bar chart, like a graph, you're given a chart and you're asked to find a mode and you're confused, write out the data. So when you write it out, it's an easier way to find out how much of each number you have. So based on that, you would get 1. The mode is 1 hat because there are 7 ones. Does that make any sense?
Yeah.
Okay. So for the errors, these are the mistakes that people make the most during, like, when they're asked questions like these. It would not be 7 because 7 is just how many times it repeats, but 1 repeats 7 times.
Yeah. Mm-hmm.
Same for this one.
3 years repeating 3 times.
If anything, yeah, so like in the raw data would be 0, 0, 0, 2, 2, 2, 3, 3, 3, but 1 would repeat 7 times. So those 3 numbers, like the frequency for 0, 2, and 3, they don't matter when it comes to mode.
In other words, like when you're looking for the answer, don't like once your answer should only be in the hats column. Your answer shouldn't be in the frequency.
Mm-hmm.
Unless, say for example, you had the highest number on there was a 3, and that was also the number of hats that was there. So like your answer shouldn't be coming from the frequency column. Your answer should be coming from the hats column. You're just using the numbers in the frequency column to figure out the answer for the hats.
I got that.
Can I move on, or does anyone need more time?
We can move on.
Okay, cool. Same with this one. So basically we look in this area to find the answer, and then but we look at the frequency to determine the answer. So the highest number is 10, and then that corresponds with this.
16.
Yeah, so that is the class with the greatest frequency. And that's called the modal class.
I got that. Okay.
Okay. So MG, this is where it really tripped me up.
Okay,
Yeah,
yeah,
me
I
too.
think I understood this. So, you guys know, and I'll probably annotate, so that might be easier. I was confused with Mira as well in the beginning. I was really confused how they got this number, but I think I'm starting to understand this now. So, obviously, you guys know average or the arithmetic mean, as we call it. Okay, so it'll end in 10 minutes. We'll finish in 10 minutes.
Yeah.
It's the sum of the data values over the number of data values. So say, for example, I had 3, 5, 5, 7. The average or the mean would be 5 plus 5 is 10, plus 7 is 17, plus 3 is 20. 20 divided by 4, and that would be 5, right? We know that. That's straight and simple.
Mm-hmm.
Now here, this gets confusing because what this is saying is that the frequency of whatever this is. So you might think that the answer is just 15 plus 24 plus 20 plus 12, 6, 2, 0 divided by 1, 2, 3, 4, 5, 6, 7, right? You might think that the answer is the sum of this divided by 7. But the reason why it's not that is, oh, I have to use the eraser here. Use that. Okay. So the reason why it's not that is because this is the frequency of that. So in reality, the data set is 7, 7, 6, 6, 6, 6, and so on and so forth. So really, there's more than one of that. So you have to count each of them. That's why they're adding up the frequencies, because what this tells you, if I add up 2 plus 4 plus 8 plus 3 plus 2 plus 1 plus 0, that gives me 20. And what that tells me is that actually I had 20 total numbers in my data set. That's why the numerator is 20, and that's why it's not 7. And in the numerator, obviously, the reason why we take f times x is because since I have 2 7s, if I multiply those together, I get 14. If I have 4 6s, if I multiply together, that's 24. And so on and so forth. And if I multiply each of the grades by the frequency that they occur, I can add those together to get the total sum of the data values, which is the numerator. And then the number of data values is the number of frequencies, essentially. Does that clear this up a little bit more, and why it's 98 divided by 20 and not 98 divided by 7?
Yeah. Because when you explain that when the frequency ends, like you have to count every single one, that made way more sense than why you got 4.9 in the end. That makes more sense. Write that down.
Wait, MG, if you put this in a calculator, will you get the same mean, like for stats and like calc?
So yeah, but the thing is, you have to specify, like when you enter it in, I don't know how you do it in the calculator, honestly. I've forgotten, but you would need to enter 7 twice. You would need to enter 6 4 times, 5 8 times, because that's what this column is saying, frequency. I don't know if there's a way to specify that in your calculator where you can specify the frequency directly, but that's what this frequency means.
So it would just be easier to use the formula that they gave us.
Yeah, so it's, yeah, in this
Okay.
case, it's just easier to go ahead and do what they're doing, where they add these up, and then you divide this over this.
I got you.
Wait, actually, I got it. It works when I put it in the calculator.
It works? Okay, good.
Yeah. So like what we learned in class with the stat, and then you put all the numbers in L1, and then L2, and then when you go press stat and go to calc, it gets you 4.9. So if you're ever confused and you think that you're doing it wrong, I think you could use a calculator, because I got 4.9 at the top. So I'll do it again. So for stat, you press stat, and then you press edit, enter, put 7 6 5 4 3 2 1 in L1, and then you can put 2 4 8 3 2 1 0 in L2. Press stat again, go to calc, make sure it's in one variable stats, make sure L1 and L2 is filled out.
I see. That's why it works,
Other
because
than
you
double-
said it's one variable.
Yeah.
So that's why it automatically knows, the calculator knows that the second column is frequency.
Yep. So I would say use a calculator for this one, because if I had to do it by hand, I feel like I would mess it up, but that's just a personal preference.
There's so many areas to go wrong.
Yeah.
In stats.
Can you go over how to do it on a calculator again?
Yeah. Okay. So press stats, and then make sure there's edit, and then press enter. So do you have the L1, L2 columns?
Mm-hmm.
Okay. So in L1, you would put 7 6 5 4 3 2 1, everything in grade.
Okay.
And then in okay, I'll tell her why I answered the call on her. Okay, and then in L2, you would put the frequencies. You would put 2 4 8 3 2 1 0. Okay, so once you do that, you press stat again, and then you press the right arrow.
Static end.
Stat again, press stat one more time. Like once you've done putting in all the values, you press stat. And then you go to calc, which you press the right arrow button, and then make sure you're on one variable stats.
Okay.
Press enter, and then make sure next to list, there's L1, and make sure next to the frequency list, there's L2.
Okay.
Okay, and then once you have those, you press enter, and then the first number you should get would be 4.9. Did you get it?
Mm-hmm.
Okay, good. Darby, what about you?
I don't have my calculator, so I'm writing it down.
Okay. If anyone else has any questions, you could message me through Slack, and I should be able to help you after this too.
All right.
Okay, for this, we have 4 minutes, so I think this is just like an example, so I'm going to skip through this.
And if anything, the recording will stop, that's fine, but we can, just reopen using the same link if we absolutely need to.
Yeah, okay, so I'm going to skip through this. If anyone wants to stay back, we can go through it. Or is that fine?
Did we go over this in class?
Yeah, so what you would do for this, oh shoot, okay, this is something different though. So
Go ahead, explain it, that's fine. We can restart the meeting.
Okay, so for this area, right, since it's a frequency, you want to take the mid-interval value. What that means is, let's say you do 2, right? So you see these two numbers, you take 0 plus 2, and then divide that by 2, and then that would be your mid-interval value.
Oh, okay.
Yeah, so basically it's the same thing with another step. And then you would take 4 plus 2 divided by 2,
and you get
3. So basically the same thing we did with the other set of data, we would take these sets of numbers and we would put that into L1 in the calculator, and then we would take these sets of numbers and put that into L2 in the calculator and do the same steps again.
Okay.
Just to clarify that if they don't give you that second column of numbers like the FM, all FM is multiplying F times M. So you take the frequency times the mid-interval value.
Yeah.
All right.
Wait, so it's 0 plus 2 divided by 2 equals that mid-interval value?
Mm-hmm. Yeah. So that would apply for everything in this column. So 8 plus 6, 14. 14 divided by 2, 7.
This is when you have histograms because it's giving you intervals, right?
Yeah. So that's a clear way that this would be this would be put on a histogram, not a bar graph.
All right.
I just got confused because I thought whenever you said that, it was talking about the number that was next to the interval. So, like, it would have been that. But...
Okay. So everyone got it? We're good?
Yeah.
Okay, cool. And then median. Median is when you're given a set of data numbers, but sometimes they always put these on like standardized testing for sure. They always give you numbers, but they never put it in order. They always do this to mess you up. So because you're always like stressed under time and you just take the middle set, but that's not what you do. You have to put it in numerical value. Yeah, you have to put it in order, and then you take the middle value.
And then if it were like two numbers in the middle, you just add them and divide by 2, right?
Yeah, that's basically the easiest way to put it. That's called the median formula, where you would take the two center numbers divided by 2, and that would be your answer for the median.
All right, cool.
And then this one, we don't have to go through this because it's on the PowerPoint. That's just
extra.
Yeah, but if the mean is the most used by like globally, means the most accurate to represent data in a set.
One thing I do want to ask is, what if this isn't like, these are conceptual questions that show up on a lot of tests, is what does it mean for your mean to be higher than your mode? That means you probably have an outlier that's a little bit high, and that's affecting the mean, and it's causing the mean to be higher than the mode. What happens if your mean is lower than the mode? Same thing, you have an outlier that's too low, and that's affecting the mean. We generally want our mean and median. I'm sorry, I've been saying mode. I meant to say median, because the middle value is the median, right? We want our mean and median to be pretty much the same. That's a good indication of that it's a good data set.